Hello friends, in this video I'd like to present my solution to the following problem from the Finnish high school mathematics competition, final round 1999, problem number 2. So suppose that positive numbers a1, a2 and so on up to an form an arithmetic progression. Prove that 1 over a1, a2 plus 1 over a2, a3 and so on plus a1 over a sub n minus 1 an equals n minus 1 over a1 an. So my hints for this problem, first of all, make use of the fact that our progression is arithmetic, so use the well-known formula for arithmetic progression, which goes like that. And then it is possible to transform our sum to make use of telescoping to simplify it. So give it a try and see you in a moment. Okay, so my solution. Since our progression is arithmetic, we know that ak equals a1 plus k minus 1 times d for some real number d. Okay, and now I will consider separately two cases. Why? You will see in a moment. Case number one for d equals 0, so when our sequence is constant. What happens then? Then we have a constant sequence, and so since our sequence is constant, I can replace every term by a1 an, a1 an. How many terms are there? Well, counting our indices from 1 up to n minus 1, we see that we have an minus 1, a1, an. So our formula holds in this case. Second case, case number 2, when d is not equal 0. What happens then? Then I will write our sum using this handy sigma notation. 1 over ak plus 1. Okay, now we can substitute our formula for the kth term of our progression, and we will get a1 plus k minus 1 d, a1 plus kd. Okay, now in the denominator we have a product, and this product, this entire fraction can be split into two fractions in the following manner. So in the first denominator we will have this, in the second denominator we will have that. Okay, the only question is what's in the numerator. Well, it's pretty easy to see that if it were 1 in the numerator, after making it again a single fraction, we will have a1 plus kd minus a1 minus k minus 1d. So it would be, after simplification, just d. But we don't want to have d in the numerator, but 1. How to deal with it? Well, just simply divide numerators by d. And here we see why I split my reasoning into two cases, because this step would be illegal for d equals 0. And now let's write it as two different sums. 1 over d can be put in front of our sum. Okay. And likewise, here we also have a1 plus kd. Okay. And look, these sums are very similar. In fact, I will move the index of our first sum by 1. So instead of k, let's write k plus 1 everywhere. And we will have a sum from k equals 0 to n minus 2, 1 over a1 plus kd minus 1 over d, sum from k equals 1 up to n minus 1, 1 over a1 plus kd. And here we see that almost the entire sum disappears, but for the first term in our first sum, so a1, everything disappears in the second sum, but the only term remaining is 1 over a1 plus n minus 1 times d. Yes, exactly. And now let's combine it. So first, let's see. First of all, this is a sub n. So we have 1 over dA1 minus 1 over dAn. And let's write it in a common, with a common denominator. An minus a1. And now if you think about it, an minus a1, our progression is arithmetic. So the difference between nth and first term is n minus 1 times the difference. And finally, d disappears, vanishes, and now we have just n minus 1, a1, an, which was desired, yes? Which ends our proof. What erat demonstrandum. Okay, so thank you for watching, hope that you learned something and see you soon. Goodbye.